All right, in this question we're asked to classify differential equations in terms of being separable or linear or neither. I'm going to look at each statement one at a time. The first statement says, so which of the following statements is true? The first statement says that both 1 and 2 are separable. The second statement says that 2 and 3 are separable, and so on. We're going to check each claim here. What does it mean for something to be separable? So the differential equation, DE, is separable if dy by dx is equal to f of x times g of y. If we can write the differential equation in this form, because then we can separate out the variables. DE is linear if we can write it as dy by dx plus y times p of x is equal to q of x. Now we will classify as one of the following. It'll either be linear, separable, linear and separable, because it can be both, or neither. I'm going to check each differential equation to see which category it falls into. So let's look at the first one. Well, this is definitely linear because we can write it as dy by dx plus y times x squared is equal to x squared. So it's linear with p of x equals x squared. How about separable? Can we write it as separable? Well, that would require us that we write it as dy by dx is equal to a function of x times a function of y. Let's try really hard to do that. I'm going to isolate for the dy by dx because that's what separable has. It has that all by itself. So dy by dx is equal to x squared minus x squared y. And can I write the right-hand side as a function of x times a function of y? Absolutely. I can common factor the x squared out. And I have 1 minus y squared. And then we can separate the variables. dy over 1 minus y squared is equal to x squared dx. So it's also separable. Let's try the next one. See what happens with the next one. So this is a both situation. It's both linear and separable. We can solve it both ways. Okay. So you may stare at it a little bit and think, oh, it doesn't look like either. It doesn't look like I can separate. It doesn't look like it's linear. Let's try. So can I write dy by dx plus p of x times y is equal to q of x? No. No matter how you rearrange the right-hand side, the e to the x plus y, it's not going to be linear in y. Not linear in y. Something is being done to y that is not a linear operation in y, or exponentiating it. Can we write it as separable? And the answer is yes. We're going to use a law of exponents. Use b to the m plus n is b to the m times b to the n. Use an exponent rule to split up the right-hand side. So we have dy by dx is equal to e to the x multiplied by e to the y. Still not linear in y, but I can now separate the variables. So dy over e to the y is equal to e to the x dx. so separable. Let's classify the next one, even though we're able to answer the question now. Yeah, I know it's circled already, but just a screenshot of the quiz the practice quiz as I answered it. All right, so the next question. Is this one linear or separable? So can I rewrite it as dy by dx plus y times p of x is equal to q of x? And the answer is no. It's not linear in y. We're doing something to y that's not a linear operation in y. We're plugging it into a log function. Okay, so our next thing is, can we write it as separable? And what are our log properties? We have ln of m times n, ln of m over n, ln of m to the n, but none of those apply. There is no rule to split ln of x plus y into f of x times g of y, right? Nothing we can do. If it was ln of x multiplied by y, we could split it to ln of x plus ln of y, but that wouldn't help us much either. If it was ln of x to the power of y, we'd be set. We'd just bring the power down in front, and we'd have a function of x times a function of y. So it's neither. Not linear, not separable. Okay. And then the last one, is it linear? Is it separable? Let's see. Can I write it in that standard form? First, for linear first, kind of. Looks like it's close. I'm going to multiply both sides by x. So dy by dx is equal to negative, or not equals, sorry. So multiplying everything by x minus x to the power 4 times y is equal to x e to the x. And the reason we did that is for linear form, there can't be anything in front of the derivative term. Right now there's a 1 over x, and to get rid of it, if I multiply by x, that'll take care of it. Okay, and it's almost there. I just have to absorb that minus sign into the p of x properly. There's no need to identify what p of x is, just it's linear. Can we write it as separable? So let's try. I'm going to take the form that we just ended with, dy by dx minus x to the power 4y is equal to x e to the x. I'm going to get the dy by dx all by itself. So dy by dx is equal to x e to the x plus adding x to the 4y on both sides. I get this. And we cannot factor out something for x. We can't factor out something for y. We're stuck. Cannot factor into f of x times g of y. So it is not separable. Now let's look at the statements. Statement A says that both 1 and 2 are separable, and that's true. So we can just circle it. But let's move on and check the other ones. Both 1 and 2 are separable. Sorry, 2 and 3 rather, 2 and 3. 2 is separable, but 3 is not. Statement C, the first one's linear. That part's true. And the third one's separable. That one's false. 5 is not linear. That's false. It is linear. And then both 2 and 3 are not separable. Well, that's false because 2 is separable. So that's just an explanation as to why the other statements are false. Just going through that language a little bit carefully with you.